is going to talk about what is Scroll and Scroll architecture. Actually, I have a very good talk with Vincent a while ago during the Hong Kong Web3 festival. We went to a coffee shop and we chatted for very long. He's very knowledgeable in everything ZK related as well. So, and roll up, so definitely ask him anything that you want at the Q&A session or even during the mingling session. So I'll pass the time to Vincent now.
Okay. I noticed the host mentioned the English issue. I can understand part of Cantonese, but I cannot catch the whole sentence. But my English is also not well, so don't be shy. If you want to ask me any questions through English, it's okay. And let me take off my mask actually. Hi everyone, my name is Vincent Jin. You can also call me Chuhan Jin. This Chuhan is my Chinese first name. I think it's not hard to pronounce it through your language, I guess. And I'm glad to attend the first 852zkNight here and give a speech to you. And also I want to thanks again to Cassie who invites me to here. I think it's fascinating to see so many talented developers in Hong Kong, and I'm also happy to make a connect with Hong Kong Web3 developers community. Before I start today's topic, I want to share my little story about how do I join Scroll to you guys because I think it might helpful. So I graduated at 2020 from NYU, and I obtained my master's degree of computer science there. I have a strong interest in blockchain technology about like 5 or 6 years ago. During that time, it's still a bull market time. The reason I get my eyes on the blockchain technology or crypto industry is because the token price, right? The Bitcoin and Ethereum. But after I read some white papers about Bitcoin and Ethereum, I immediately realized that the price of those tokens is not based on air. It actually stands for something, the decentralized philosophy. And also, this philosophy may change our world in future. Compared to Bitcoin, I love Ethereum more because, the founder, or we can say the father of Bitcoin, Satoshi, he's a mystery guy. You don't know his background story. But Vitalik, the founder of Ethereum, you can read his story through the internet. And I think he represents the young people with a very good idea and make it such a success. What this experience reminds you to, I think, is the golden age from Web 2. When the Web 2 started to grow, there's a lot of young, talented people with good idea, and they made some startups and achieved huge success. So this happened in Web 3 industry right now. So I think now it's a golden age of Web 3 industry. I'm super glad that you are joining this Web 3 industry and believe decentralized philosophy now. I believe, I really wish every single of you can achieve your dream, can make success through this industry. Okay, so let's go back to talk how I joined Scroll. So it was 2021 when I read the articles written by Vitalik. He discussed the roll-up solutions for Ethereum. He mentioned two solutions. One is optimistic, and another one is ZK. I believe this two approach has been explained by Jonathan, the first speaker, well. So I will skip the details about it. And he also mentioned at the end of the article, he believed that ZK rollup would be the final solution for the Ethereum rollup roadmap. So, and immediately, and after that, a short time, I realized, I noticed there is an open source project called zk EVM, which is initialized by Ethereum Foundation PSE team, which is also the team Cassie works for. Because it's open source, so I joined their community call several times. And I noticed during the community call, there's many members there have Scroll tag. And if you check the GitHub repo of the zk EVM, you notice almost over the 90% of contribution and made by the people who have Scroll tag. So I realized there's a team called Scroll, and they have gathered many like good zk engineers and the cryptographer. So I noticed there's one scholar called Zhang Ye. He's actually my alumni. He also started in NYU. So approached to him, and he told me he actually is a co-founder of the Scroll. So I said, could I do anything for the Scroll? Because I really like your project. I like the idea of the zk EVM. He is not saying okay immediately. He's saying, if you really like the project, you can do some contribution by yourself. Let's see. So I made some contribution. I pushed some code to the Scroll's code base through community. And after several successful commitments, Ye said, yes, thank you, Chuhan. I think it's a time to ask you to join our team officially. Then I become a developer in Scroll. And now the stories continue. I become the co-developer here in the infrastructure team of Scroll. I want to share this experience is because I think it may helpful for you, because I think many of you are developers, right? So if you really, really want to join any Web3 project or company, don't short-sight it. You can always make some contributions through community. Don't ask for the short-term reward immediately. Just take the long term. I think eventually your contribution will noticed by the entire community, and will noticed by the team, the project, and you will eventually get what you want as a reward. So that's my story. That's quite long, right? Let's jump to today's topic. What is Scroll and Scroll's architecture? Okay, Ethereum is great, as everyone knows, because it's extend the blockchain, making it not only a book to record your transactions, your money's balance, right? It can also empower to help you to run some smart contracts to build DApps based on it. So it's decentralized. Everyone can join. Everyone can interact with the blockchain by themselves from anywhere. No one can say no. And it's secure because of it's decentralized, and the consensus algorithm design behind it is secured. But it's not scalable. That's a long time existed issue that even when Ethereum is be designed, this issue has always accompanied with the Ethereum. If you take a look about the Ethereum's TPS, it's incredibly low, and this will bothering users by this way, the gas fee. So when some GameFi launched or some popular NFT mints opened, people are always experience high gas fee. If you take a look at the picture, you can see the gas fee is around $132. I think that's unacceptable, right? It's if you want to buy a NFT, it's worth only $10, but you have to pay like $100 gas fee. Will you buy it? Will you mint it? I guess the answer is no. And it's also recalled one of my memory. I tried to deploy abstract wallet on Ethereum 2021, and the gas fee is even more. It's around $200. And compared to go to some local market to buy some cold wallet, why do I have a reason to deploy abstract wallet on the chain? So yeah, you see the scaling issue is bothering Ethereum a lot, bothering the community. So we need to find a way to decrease the gas fee, to increase the TPS. How to solve scalability? Vitalik think a lot of ways to do that. So I mentioned before, optimistic rollup and zk rollup. So Scroll is a zk rollup solutions to scale Ethereum, and our answer is the bytecode equivalent zk EVM. I think about the power of ZKP, Jonathan has already explained it well to the audience. I guess you all get the idea. And just in case if you don't know, you can raise your hand and ask me some details about it. Okay, so unlike the other approach to the to scale Ethereum, zk EVM is use ZKP. We generally simplify to say that it's we write zk circuit to generate ZKP for every single opcode of EVM. So as you know, the smart contract goes to EVM. It will be compiled to some series of opcodes, and then EVM will perform it. And we use zk circuits to make sure that every performed opcode has successfully and correct performed. So this is called zk EVM, the zk version of EVM. And it's because we built it through the level of opcodes. And so it can be so-called bytecode equivalent zk EVM. To human readable or understanding words, it will perform exactly like EVM with no difference, 100% equivalent. And Scrolls, in order to scaling the Ethereum, we have some principles and our vision. First important is EVM equivalence, because only that can make sure our user trust us. Otherwise, it will cause some issue. I will explain later. And security first. Of course, trust means trust means the security is good. Your security is good enough to make people use your product. And decentralizations. That's why in our roadmap, because we are the first layer 2 project to announce that we're gonna decentralize our prover, decentralize our entire network, and we are community first. Through my story, you can get an idea about our culture. We are very valued our community. So yeah, if you want to copy my path to join Scroll, you can also start to contribute to our community now. So how do we compare to the other solutions? The difference. That's also the point that I explain why the zk EVM is important. You can notice the leftmost, the rightmost side is Ethereum. The standard workflow from Ethereum through Solidity to the EVM, to performed in EVM. The box that equivalent to Ethereum's workflows, I marked as a different color. So if you can take a look at the other approach, Stockware, zkSync, Polygon, they only partial equivalent, but our workflow are exactly equal to the Ethereum. Why is it important? Because you can see these two approaches, they are through language level, they are different. For Stockware, they use different language other than Solidity. For zkSync, through language level, they have another VM. Through Polygon, and Polygon is different. But Polygon have make some extra compiler layer in bytecode level. So it's not bytecode equivalent to EVM. Only us are entirely equal to the EVM. So for example, if this layer has some difference compared to Ethereum's workflow, it can make trouble. If your Solidity has, for example, if Solidity has a function called transfer, if you compile the transfer function into this level and have some difference compared to Ethereum's standard workflow, standard generated bytecode, it may make your zk proof not valid for it, and thus your transfer is not going to work. That can make troubles, or even make people lose money. I should call it disaster. So you got an idea why the fully equivalent zk EVM is very important, and that's what that's also our core stone for Scroll. Okay, zkM is great, but what else we need to build up a layer 2 project? So we enter another topic about Scroll's architecture. I go over the first part very fast because I think Jonathan has already covered most of the materials. So I want to start the second part through a very innovative way. I want to encourage you to think about it. So zk, just imagine, because many of you are developers, I guess. So I think in your career goal, you might want to be a CTO one day. So just imagine that your dreams come true. Now you are a CTO of Scroll. Now the PSE team gives you the open source project, zk EVM, and it's reliable and stable, can give you some proofs to prove your block actually being performed off-chain. So what else you need to create a layer 2 project for users to use to experience the low gas fee, higher TPS? Any audience can guess. I can give you some start point. your zk EVM should run on some machines that have high computation power. Okay, we call it prover. So the hint is, through the data stream flows directions, what else we need? Think about the input side. Anyone can guess? Don't be shy, or I give you like 20 seconds to think. Uses. What? Uses? Not exactly. I'll give you another hint. Prover will take opcode as input. So what generates the opcodes? Any guess? What? Trust mark? Yeah, opcodes. Or I think Jonathan, the first speaker also mentioned that word. Yes, the sequencer. You're right, sequencer. So sequencer is the answer. It's like the upstream or the generated input to the prover, which zkEVM is running on. So because the zkEVM takes opcodes as input, what do you think the best fit for the sequencer to be? Because there is already existed one to become the best native sequencer for us. Oh, this is maybe a hard question, but actually the answer is super simple. Another GoEtherm fork, or another EVM, right? So EVM can help us to arrange order the transaction and generate opcodes with ordered. So we can use it as input to zkEVM to prove that our EVM actually did the right things. Is that simple? Yeah, but it's a little bit tricky. But so in our definition, sequencer serving as an extension of the gas fork. It's a gas fork actually. The sequencer provides additional functionality for orchestrating the creation of roll-up roofs. The sequencer is intended to launch only if it can connect to Scroll version of gas, as it is fundamental for many of the functionalities. The last sentence means, because in our roadmap, we're gonna decentralize our sequencer. So if you wanna launch your own sequencer node, you have to connect to the Scroll's network. Otherwise, maybe you connect to the GERDI or you connect to the mainnet. It's not Scroll's sequencer. But in simple words, our sequencer is just a gas fork. It's that simple. And because it's gas fork, so people can trust us, it's equivalent to EVM, and the zkEVM takes the same input as EVM take. Okay, besides the sequencer, let's think about the output, the data output stream. What is another question mark should be? I think the first speaker also mentioned that. Yes, verifier, you're right. But to be more specifically, I think it's smart contracts on the Ethereum. Because verifier cannot always, if you have off-chain verifier, it can never guarantee the outcome, right? So the real verifier is located on the chain, on the Ethereum itself as a smart contract. So we submit the proof to the Ethereum and to the Ethereum smart contract, and the smart contract take the proof and verify it on chain and gives you the, if it's right, if it can be passed to verified as a valid proof, we will record it on chain. So through this way, we can make Ethereum as our security foundation. We utilize Ethereum's security power. Okay, let's go. So we have L1 contract. But here's raise a question. How do you write your proofs to the L1 contracts? There's another word. Sorry, so many words tonight, but another words that appeared everywhere in city. No. If you have a road, you can link the building, right? If you want to, yeah, bridge, you're right, bridge. How to write proof to layer 1? It's bridge. Why we call it bridge? For a reason. Because as you know, the bridge protocol or bridge, I think the bridge project is linked to two different chains, right? So, but in fact, the layer 1 we call Ethereum itself, and layer 2, any layer 2 is an independent chain. In fact, it's two separate chains. So you need some bridge to link to them, link the assets on it, link the link the proof of it. So bridge will do more things and then just write proofs to layer 1. It relay deposit events to the layer 2. It will relay the withdrawal events on layer 2 to layer 1. So if someone wants to withdraw his money from layer 2 to layer 1, it will go through the bridge. And it can do more things. Don't limit your imaginations. For example, maybe we can put a gas oracle into bridge. It can give me some gas estimations, so I can relay the message more efficiently with lower gas fee, or I can relay some important message with higher gas fee to increase the speed. It can also maybe it's just my imagination. Maybe we can relay the entire contract state into the layer 2. That we simulate a run of the smart contract on the layer 2. That is very interesting. So don't limit your imagination with bridge. Bridge could do more things, and bridge is what we have right now in Scroll. If you are a CTO of Scroll, you definitely want to have this. Otherwise, your users cannot transfer their money between chains. Okay, let's go. Besides the bridges, we also need one additional part, because we, as you know, we not only have one prover. I tell you a fact that a prover it's complicate like power consuming of the prover and also time consuming. If you want to generate the proofs, it may take you up to like 20 or 30 minutes or hours if you have a weak machine. But if you only have one provers, if you layer 2 generate blocks like for example like 3 seconds per block, after you create a valid proof, there will be a lot of unverified blocks awaiting for you to prove. So we need more provers to generate proof like parallelly for different blocks. Since we have many provers, should we manage it through some way? The answer is it's not necessary. It's not necessary because we can always let provers handle this by themselves. But better to have, because if you really let the provers handle all the things, they will create a chaos. Imagine this way: there's like 10 provers competing to creating a same proof for the same block. It's like the wasting of the computing power, all right? And some of them may also wasting the gas fee when they're trying to submit the proof to the layer 1. So I don't think it's a efficient way for the provers. So we have the manager of provers. We call it coordinator in our architecture. What coordinator exactly doing? It distributes the traces, which is like the ordered opcodes as input to the provers, like assign a task to them, ask them to generate proof. Another additional function of the coordinator is to pre-verify the proofs, because you don't really want a prover to submit the proof directly to L1 smart contract, because if it failed, you wasted your gas fee. So we give them an opportunity to pre-verify the proofs. If it's failed, then the prover itself don't have to pay the extra gas fee. We also maintain the traces from the L2JS, which is so-called sequencers. We manage them. We mark some traces has been proved or not, or if some traces has been proved for too much time, I mark it as a timeout and reassign it to a new prover. So through this way, we can increase our efficiency. And there's also a question mark. Actually, coordinator can do more things. So like I said, don't limit your imagination. I give the one example, aggregate proof. Actually, coordinator can run an extra zk circuit. We call it aggregate circuits to aggregate proofs to become a proof. It could like rearrange the proofs to become a bigger proof, but the verifying time is still limited. So through this way, like we can aggregate like 5 proofs from 5 different provers into one proof, and they share the gas fee to submit to the layer 1, right? So we decrease the gas fee again. So with this power, you can imagine our Scroll layer 2 will have a super low gas fee compared to the Ethereum. I guess maybe, for example, the picture, $100, right? The gas fee. I guess it's in the same case, Scroll may only ask you for 0.1 USD, 1 of 1,000. Okay. So now as a CTO, with all the components that you need to have to build a layer 2, we have overall pictures here. We have L1 contract, right? It's our security foundation. We have gas, a forked gas, which served as a sequencer of our layer 2, right? It generates trace. The trace include execution logs, block header, transactions, contract, bytecode. Actually, it will be translated to bytecodes part, and we'll use it as an input feed to the prover. Prover will run in zk EVM circuits. It will generate proofs for every single opcode, and we'll go through the aggregation circuit to generate the aggregate proof. And aggregate proof will be sent to the coordinator. Sorry, this coordinator part and verifier part, bridge part is be skipped, but I will expand it. There's another complicated picture later to show you. But when you have a proof, you send it to the coordinator. The coordinator will pre-verify the proof. It is validate. We will reroute it to the bridge. Bridge will write it on the layer 1 contract, and then the entire loop is closed. Your security is being secured on the Ethereum, and your off-chain computation is performed by the sequencer and zk EVM. So good job. You increase the TPS, and you have a layer 2 chain ready for user to use. Here is more complicated pictures here through the network level. Sorry, I didn't expect our today's screen is that small, so you might look it very hard. But I can explain to you. So this part is sequencer part. You can say it's layer 2 POA network. What is POA? It's proof of authentication. So in current timeline, we haven't make it as a decentralized consensus. So POA is a centralized consensus. It's proof of authentication. This is layer 2, so-called sequencer. And here is our bridge. Here is our coordinator. They all link to the layer 1 Ethereum and through some way to link to the sequencer. Remember, bridge will relay the message from the layer 1, also will relay the message from layer 2. Coordinator will link to those is called roller, also called prover. Link to them, they will distribute our task to them or blocks to them to generate proofs. Okay, so you got this part very clear on this picture. It's not secret. It's if you take a look at the IP address is pre-alpha. Currently we are at the alpha testnet, but the overall structure not change a lot. Okay. So for users, based on what I'm talking today, for users and developers, Scroll equal to Ethereum if you want to develop any DApps on it. You don't have to learn a new language. You don't have to bothering if your smart contract would acting different in Scroll. Our hackers on some hackathons, even we hosted their experience. The only thing they want to do to migrate their DApps to the Scroll is just copy paste without changing a word. So currently, we're at the road to launch our mainnet. A few months ago, I think 2 months ago, we launched our alpha testnet on Gurley. Now you can interact with it if you have Gurley ETH. If any of you really want some, you can ask me later in the mingling time. If I have some Gurley ETH, I can share some to you. And our next big target is to launch our mainnet at the end of Q3 expected. And after we launch our mainnet, we will decentralize our prover network. It is not hard to do that because you can always have your, imagine this, you can always have your coordinator to be open sourced for anybody. So everyone who want to join our prover network can create their own coordinator. So for the provers, they are not only have one choice, they have so many choices, which is also the decentralized way for the proving system. And our last phase 6, is decentralized our sequencers. Decentralization is always good idea. It's a good philosophy. So we will keep moving, keep become more decentralized. And decentralized sequencers is not a hard work also, because as you can see, currently our sequencer is running proof of authentication. If we switch this consensus algorithm to some decentralized algorithm, then it will become decentralized. So it's not that hard also. So before we go to the mainnet, we still have something left to do. We need to complete the entire zk EVM circuit. We already finished all of the opcodes, but we still want to fix some uncommon errors, add some pre-compile contracts. But for the opcodes, it's 100% complete and equivalent to the EVM. We also need to do auditing to audit our zkEM circuits, audit the bridge contract, because bridge is very important, as you know. It's transfer the money between the different, or the assets between the different layers. So we should take it very careful. And we also need to do the optimizations for our provers through the algorithm way or the hardware way. We can have a better hardware to run our prover. Excuse me, to increase the speed of generating proofs. Right now on our alpha testnet, we have 3.1 million unique wallet address deployed, and we have totally 15 million total transactions and over 582K contracts deployed. Those data should be updated recently because every day the data goes up. Since our Scroll's alpha testnet, we have 150 plus hackathon projects deployed on Scroll. Recent big ETH event like ETH Denver, we have 100% plus deployed. In ETH Beijing, we have 60 plus projects deployed. We also launched our ecosystem page. It shows like 660 deployed ecosystem projects. Some big names include Uniswap, AAVE, Hop Protocol, Anchor. This is an ecosystem page currently that we launched for the first round. We have also a second round, third round. There's also many ecosystem projects they haven't shown. But you can also notice there's some familiar one, right? Have SushiSwap, OK Wallet, multi-chain, Anchor, right? So we keep growing and welcome more people. Or if you have your own startup project, welcome to deploy on Scroll and join our ecosystem. This is how you can get involved. If you have your own project, you can scan this QR code and submit do like a quick survey, and we will take care of your project and try to put it on, try to help you join our ecosystem. We will help, like I said before, we are the community-driven culture team. So we will give a lot of support to our ecosystem project. You can find Scroll is a fully decentralized team. We have team members all around the world. 24 time zones, we all have our team members. So if you want to find another Scrollers, you can go to those ETH events, right? Just happened, ETH Tokyo, ETH Taipei, we all send scholars to there. And I personally will plan to go to ETH Istanbul at November, but it's still a long time away. But if you have any of the plan to attend those events, you can find the scholars there and make connect. Okay, so here is some common stuff. We have our testnet QR code. We have our Discord. This is a very good way to join our community, Discord. And if you want to apply a job in our team, we're still hiring because we have a lot of challenge ahead. So we need more people to help us to build a layer 2, build a Scroll better. So if you want to applying a job position, you can scan that QR code. Thank you. And any question?
Yeah. Any question for Vincent?
Hi. Sorry. The one major difference I found Scroll between Scroll and the previous protocols, StarkNet, is you guys apply the snacks, right?
Private
Snack. Apply the snack.
snack.
Yeah. SNAK, right? Oh, sorry, SNARK.
Okay.
And they apply the stack. So why do you guys pick snack?
I think the different zk algorithms have different advantage. So zk SNARK, it's best fit for the EVM model, because if you want to create a zk EVM, you have to care about the state, the memory, storage, those stuff. And other algorithm may not fit that, but we found that zk SNARK is the best fit for it. And it also existed many like tools to help us to write the zk circuits. So I guess PSE team also considering other zk algorithm like Nova or something, but zk SNARK is still I think right now the best approach to implement the zk EVM.
Hi. If I understand correctly, Scroll is very synchronizing what EVM is doing. Is 100% EVM compatible, right?
Yes.
So what if the layer 1 EVM has some changes on the opcodes? How will that affect the Scroll's ecosystem?
Yeah, you are right. You are right. If EVM itself upgrades, like Shanghai upgrades recently, it like push 0 opcodes into the EVM. We will follow them to it push 0 zk circuits into the zk EVM. So, but you are right. So there is a time gap you cannot avoid. But we will keep following up with the real EVM. Oh, the light is too shiny. I barely can open my eyes to this direction.
Oh, we got a question here.
Thank you for the very insightful talk. So you mentioned we don't want to duplicate prover work through using a coordinator to pick the prover.
Yes.
In that case, then how is the coordinator elected, or how is it picked for the network?
Okay. I think you might asking. Some people considering it as mining, right? Definitely, we will give some incentive to the provers, of course, because otherwise provers are consuming their computation powers for nothing, right? We will give them the reward, but this is still remain under our internal affair, because we don't want to launch this officially, announce this too soon, because we are the first project that gonna support the decentralized prover, the POW community of the Ethereum, the POW community of the Ethereum, they all keep their eyes on us. So we have to be very careful to make every decision. So I cannot give you the answer here, but you will hear it soon, because as I said, as the roadmap shown, after we launch mainnet, the next step is to decentralize the prover, and during that time, we will give you the official announcement about it.
Actually, I kind of have that same question too, because it seems like it's even more risky as the traditional proof of work, right? Because you don't even need 51% to kind of attack that prover sequence in a way. Like you can you can't really attack it, but you can cause significantly delay, I guess, right? If you
sometimes it will, sometimes it will, but after we decentralize it with any other, like with too many entry points, eventually you cannot attack the entire community's entry point of the coordinator. Then I think, and also the 51% attack is not available in zk world, because we are using the mathematic power. So there's no way for any attackers using like control over 51% nodes to attack.
Testing. So I heard that in Scroll, you guys are also building like using zk-SNARK, and there's like circuits that you guys try to replicate what EVM is doing. But the thing is that in EVM, we actually keep updating like all the like Solidity version and like the EVM compiler constantly. So how you guys be able to keep track of in terms of update? Because EVM is actually updating quite fast, and we have to design all the circuits that is quite complicated to tackle, all the EVM computations.
Very good question. But I think this is not a problem for us. Even if, let's imagine extreme case, even if Ethereum launched the version per day, but zkEVM cannot catch up. But you can always trust us that zkEVM has the same equivalent to the certain version of EVM, right? We do not have to upgrade every time when Ethereum upgrades. We always can upgrade later, because don't forget it, the layer 2 and layer 1 is a separate chain. So if you trust the previous version of Ethereum, EVM, you can trust us, because we are proven that that version of EVM is equal to our zkEVM.
Yeah. I guess that's it. Well, to put kind of what Vincent said earlier into context, not pointing to any project, but there is certain projects that are not bytecode compatible. And recently, a few weeks ago, you have heard of cases where over 900 ETH is actually locked up in the contract because some rollout project, some L2 project doesn't have dot transfer. So it's actually very true that like bytecode compatibility is kind of like a key thing when we talk about L2
Yes.
and zkEVM. So yeah, thank you, Vincent.
Thank you.
Thanks.